Our eminent chief guest.
Good afternoon to everyone. It is a great honor for me to introduce our chief guest. Scientist Mr. T.K. Sundaramurthy joined ISRO Satellite Center after completing bachelor's degree in mathematics from Sacred Hearts College, Tirupattur, a DMIT in Aeronautical Engineering from Madras Institute of Technology, MIT, and ME, a distinction in Aerospace Engineering from Indian Institute of Science, Bangalore. In his initial capacity as mission analyst, he served ISRO Satellite Center for 4 decades in various capacities, positions, and responsibilities in the spacecraft technology domain, namely mission operations, management of communications, and meteorological spacecraft of ISRO. During initial period as mission analyst, he had contributed significantly towards realization of India's first experimental communication spacecraft, arranged passenger payload experiment called Apple. Having acquired his rich experience, he moved to mission development group to take up still higher responsibilities in mission of operations of communication and meteorological satellites and served in various executive roles such as project engineer, project manager, a deputy project director, operations director, and mission director for Indian communication and meteorological satellite systems. He had extensively contributed in areas of mission planning, analysis, and operation, starting from the conception and realization on turnkey basis. These contributions have been reflected in terms of technical papers, reports generated by him, and presented in various technical forms from time to time. As a mission director, he was a main architect for the design of unrelated successful commissioning of state-of-art communication systems, ELUSAT, a joint venture Astrium and ISRO Antrix for Europe, overcoming various odds proactively during the course of realization of the prestigious project. HILAS, one another high-end communication satellite for Avanti service which is provided by UK, was another feather to his cap towards in his careers. He had special privilege for associating with an international space agency, Astrium, closely during the execution of these projects like Eutelsat and HIAS. Upon successful completion of Eutelsat, W2M operations conferred Team Excellence Award. The Team Excellence Award conferred for the successful completion of ISRO's Advanced Meteorological INSAT 3D. As ISRO representatives attended many international technical conferences, and he has also affiliated himself in various high-tech professional bodies such as Astronautical Society of India, Aeronautical Society of India, Institute of Aeronautics, Astronautics and Avionics, and etc. He is a freelance ambassador for ISRO community towards the promotion, outreach of space, science, and technology programs among students, common public, educational institutions, etc. He has visited many technical institutions in, as a chief guest. His guest lectures on various topics in space science and technology have made good impact and evinced interest among technical institutions, colleges, and higher secondary schools. Today, we are very great privileged to have an opportunity to listen him this evening. On behalf of all gathered here, I welcome you, sir, to this literacy evening. Now, hand over the session to our chief guest, scientist, Mr. T.K. Sundaramurthy, sir.
Thank you very much for giving me an opportunity to interact with the students community. My special thanks goes to Abdul Wahid Saab. I think I'm associated with this college for a long time. I think I'm enjoying, and I've visited the institute quite a number of times. As he mentioned in his welcome address, I think the environment is really good, and it is a well-disciplined institute. Next, one thing which I can say is the staffs are really dedicated. So they are trying to give the students a quality education program. That way, you students are all really gifted guys. So I am proud to say that what I was doing in MIT Crumpet. That was sometime in mid 70s. The same kind of environment I saw in the college. Though I have visited, I think more than 100 colleges and universities I have visited in the past 1 decade. Okay, well, I can say that this is one among the top ranking in terms of discipline and then good quality teachers. With this, and I thank the management for giving me an opportunity to share my views to the students community. So for today's lecture, I took the topic as opportunities for engineers in Indian space program. If you have asked me this 3 months back, then I would have told it is a limited one only. But 2 months back, I think the Prime Minister and the Finance Minister took a decision to enhance the space industry participation by private industry in a very big way, like other countries. I think India is the only country so far the space programs are being funded only by government agencies. That is, Government of India was supporting all our space programs, whereas in the world elsewhere, if you see, only private people are the main contributors for the programs, and the government support them with some seed money. That's all. Okay, probably I think 3 months back you would have seen SpaceX. A private company has sent 2 astronauts to the International Space Station. And, last 2 weeks back, they have brought back them successfully also. So this has happened in a matter of 2 decades. That is, Elon Musk has started this in 2001, and he has successfully completed in the 19th year, sending a human being astronaut and then receiving it. I think like this in India also, I'm seeing with this now opening up the space sector to the private people. Many industry people will come forward and then they will take the space program in their platforms. That in turn will create a lot of job opportunities for the upcoming students. So to start with, what I'll do is I'll just go through the current ISRO programs and what it is lined up, then how the private participation is going to take it forward, and how the job opportunities are going to be created. That's what I'm planning to cover in another 45 minutes. Okay. I think with this, okay, if you have any queries through your HOD, you can contact, or there is an email I have given, Kapila, Kapila 666 @gmail.com. Okay. I think with this, now let me go to the next slide. Okay. I think we all know. Okay. This is the kind of a situation where we are. The present scenario, if you really look at it, we don't know. For the past 6 months, we are all now, trying to find a pathway in the dark. That is the kind of a situation COVID has left us. So I think, yes, but any problem, we will have a solution. Okay, that is what. I think if some problems are there, then only we will overcome them by using our intelligence, and then we will find out some new things. So with these expectations, I am definitely sure we will come out of this pandemic situation with still vigor, and a good success is going to be there in the coming days. This is what we are going to make it. I wish all of us will be having a kind of a orderly thing, and we will be definitely going to improve all our talents and our lifestyle in an orderly way, and then we will be keep growing. This year happens to be the centenary year of our father of space program, Dr. Vikram Sarabhai. I just wanted to give you one small video presentation about him. It's just a minute clip. Okay, I think this is going to give a just tribute to whatever space agency what we have. Um, just a minute, I'm not able to. Yeah. So I think this is how we have started our space program. When Sarabhai represented the UN Council, the developed countries were questioning him. A developing country like India can afford to have a space technology. For that answer given by him, I have just reproduced. But I don't want to repeat because you have already seen that. He has emphasized that we should be second to none in the application of advanced technologies to solve the problems of the man and society. I think now ISRO, after the 4 to 5 decades, we have met his dreams. All our programs are aiming to solve the problems of the common man. Now you talk of anything, yes, you can see some space component in that. Well, let's go to the next slide. This is how we started our initial days. That is the real program, that is that office, management office started in a church, which is called the Saint Magdalene Church, way back in 1960 in Trivandrum, Tumba. That now they made it as a museum and the people can visit, and even today they can go and see that. And these two pictures you are seeing, this is how in the early days of 60s, the sounding rockets have been taken out from the laboratories to the launching place. We were not looking for the sophisticated facilities and all. whatever available we made use. I think that is our strength. This is what I wanted to emphasize wherever I go to the students, because we should not lose our past, how we started, and now we are, yes, in a very sophisticated mode, and then we are at par with the advanced countries. But I just wanted to show you people how in the initial days people have struggled. This building, whatever you are seeing, it's a industrial sheds in Bangalore. This is where we started our building our spacecrafts. And our first satellite, Aryabhatta, Bhaskara, Apple, and all were built in these industrial sheds only. When Russians visited in way back in 1972, for the launching of our first satellite, Aryabhatta, they were questioning, it looks, the our people, because at the time I was also doing my engineering in Chennai. Then for that, they told, yes, this is where we are going to do it, and we have successfully done it in 1975. Another picture, what you will be seeing is, it's a common sight in a bullock cart, a satellite taken out. This is another innovative idea. Whatever available facility we make use, and then meet the requirements. See, the satellite has to be tested for its radio frequency interference study purpose. For that, we need to take the satellite to an open space where it is that a noise-free environment will be available. So the satellites are supposed to be taken from a clean room to that. So the tent has been made, but when we were looking for a vehicle where it could be a non-conducting platform, for nowadays what we have a specially equipped vehicle for this, and that vehicle is costing in terms of crores. But in those days, it was not available to us. Then one of our senior people come up with an idea, why not we take the spacecraft in a bullock cart to be an open place so that we can have the testing. Okay, that idea, it was worked out, and we took that, and then we did the satellite, and this satellite was launched in the same configuration, and then it has worked for 3 years. That's what I wanted to tell you. We are not looking for the facilities again. Whatever available, we made use to meet our requirements. This one, of course, this figure is very common to many of you people, because who have seen my presentations earlier. This is Dr. Dr. Arvamudan. Dr. Kalam is the project director for that sounding rocket program, but you see what is he doing. He is assisting Arvamudan. He is the center director. Okay, later on. But at that time, he was also one of the main engineers in designing and then launching the sounding rockets. So this is the kind of a work culture has given ISRO to this level. That's what I'm telling. That is the dedication and the kind of interest to complete the assignments in time. That is how ISRO is successful. In 1963, we started our first sounding rocket program from our Indian soil. For this, we took French assistance to some extent. That sounding rocket was called the CAHCET. Then, next satellite, Aryabhatta, was launched way back in 19th April 1975 by Russia. And we entered into the space club of the world. That is, we are the 7th in the country. This is our organization structure. Okay, this structure needs to be slightly a modified one now after the restructuring of these verticals are all formed. I think it will be taking some more time. People are working on it. Otherwise, this is the structure. We are directly reporting to the Prime Minister, and with a Space Commission to our advisory body, then Department of Space, then to support Department of Space, we have a lot of laboratories to support us, and then one commercial wing called Antrix. Then we have ISRO centers in various places of our country. That is been given in the left side and the right side. I'll not go too much into details because that is not going to be of much importance to us. But one thing I wanted to say is, if you look at this diagram, this diagram gives an idea where all our ISRO centers are having some or other facilities which is contributing towards the space program. So that way I can say Department of Space is one department where entire nation is contributing. So that may be the another reason why we are successful. Okay, now let me briefly give you the launch vehicle programs. Now subsequently I'm going to give only the currently going on programs, and then we will see. The vehicles are categorized in three different classes. One is low Earth injection orbit, and then polar satellite launch vehicles. Another one is geostationary satellite vehicles. This diagram gives you pictorially each one. That polar satellite launch vehicle, what you are seeing is it has already flown more than 50 times, and it's in that 51 we had only 2 failures. That is, that first flight was a failure, and in between, I think in the 46th or so, we had one that the heat shield was not separated because of the otherwise all the 49 flights were successful. And using this launch vehicle only, we have broken the record of Russians of having, in a single go, they have launched 36 satellites, whereas we have launched 104 satellites. And the next is GSLV, that geosynchronous launch vehicle. Its capability is to put around 2.5 tons into the low Earth orbit. Then we have further improved this vehicle to GSLV Mark III. This is the vehicle where we have launched our Chandrayaan 2 last year. We are going to use the same vehicle and modify it to launch our Indian astronauts into space. This is the spectrum of the vehicles what we had, but in that first 2, SLV and ASLV, now are not in operations. But next 3 vehicles are in operations. We are using it for various purposes, and then we are launching other country satellites. For your information, so far we have launched 350 plus satellites of other countries through this PSLV launch. This is our spaceport that is currently in Sriharikota. Whatever in the insect, what you are seeing is how the launch vehicle is being moved from the assembly bay to the launch pad. That's what you are seeing. Currently, we are having only 2 launch pads that you are seeing in this diagram, 2 tall towers. Now, as the number of satellite launches are keep growing, we are going to have one more, that is in Kolkata, in Tamil Nadu. It is coming up. I think soon it will become operational, and then our launching frequency becomes more frequent. That means the number of satellites going to be launched is going to be increased tremendously. Currently itself, we are holding the record of, in 1 year itself, we have launched more than 15 to 16 satellites in a year. That is what this is not sufficient. That number will go up. I think in the coming later part of our presentation, we see how we are planning to increase the number of satellites to meet the demands. Okay, before getting into the satellites usage, I'll say what is a satellite? Satellite, basically, it's a word derived from Latin called satellite. That means it is an attendant. That means it's a slave. It behaves in an orderly fashion by the master. Okay, that is the maid. That is the. Whereas in our context, if you look at it, it's a body moving around another body. Whereas in our case, it is earth in a mathematically predictable position, so that the satellite can be made use of after 1 hour where the satellite is going to be, how I am going to make use of it. Like that, it will be much easier for us to predict and then make use of that satellite. We'll see the categories of the satellites and then how it is going to be used. But of course, you all know the first man-made satellite was launched way back in 1957 by Russia, and it was followed by USA, and then yes, France, then Germany, then Japan, China, and India. We have joined in the line. How many more countries are going to have this? Okay, these are all the different satellites what we have built so far. I'm not going to go into too much of detail. Just I wanted to show you people how these are there in various categories. Let us see that the categories. Like launch vehicle, we are having communication and meteorological satellites. This is used for our communication purposes, TV and all those things, and the internet, all kinds of things. And then remote sensing satellites, then navigation and positioning satellites. Of course, we have to have scientific missions. Without science, there is no engineering. That's why scientific missions are also here. To start with our Aryabhatta itself, scientific mission. We will go in each category how it is classified and how it is going to be used. These are all the communication satellites of having the 1000 kg, 2000 kg, 3000 kg. As we grow, our requirements also grow, and then to meet that, our satellite masses also grows, and then that's it. Today, if you see, we have launched a satellite called the GSAT-11 last year, which was the heaviest satellite what we have launched. Its weight is around 5,895 kg. So I think that is the kind of a growth what we started with 350 kg of our Aryabhatta. Okay. And then these are all mainly used for, this is Earth observation satellites. Then environmental monitoring and then cartographic also we had the satellite classifications. Then if you look at the applications wise from communication point of view, these are all the various applications wise: TV broadcasting, mobile communications, radio networking, data collection platforms, meteorological imaging, search and rescue, disaster warning, and data collection platforms. Of course, we will see a little bit one by one. And the main use of our communication satellites, if you look at it, it's using the satellite technology. Okay, you know, we are all seeing TVs and the internets and all other things. So that's the main part. Apart from that, we wanted to utilize the satellite for other purposes. That is mainly this telemedicine via the satellites. Because you all know our country consists of villages. And the villages are not having a very good health sector. They are having only very limited medical facilities. So what we had come up with an idea of connecting the villages to a nearby high-end hospital through our spacecrafts, so that the patients in the health centers, remote health centers, they can contact the nearby high-end hospitals and then take the consultations and the treatment, and then they can be get rid of their problems. So like that, so far, very close to 1,000 such centers have been established. This is one another offshoot of our usage of the spacecraft. Second one, of course, without education, no country can develop. This is what our Dr. Abdul Kalam, our ex-people president, used to tell. So, in terms of improving the education to the entire Indian population, we had come up with an exclusive idea of launching a satellite called EduSat, so that simultaneously all the students can listen a quality lecture by a IIT teacher simultaneously. That is what? That is when the teacher teaches in Delhi, let us assume. The students present across India will be able to listen the lecture and interact with the professor in live using the spacecraft. Even now, that program is going on in a in a structured way, and then people are started using, and then many are coming into the fold. They started establishing the facility and then using this technology to spread the knowledge which is available with the very high institutions like IITs and IISc and then some NITs and all. So this is how we are contributing our space technology to improve the education of our students community. This view gives how the Delhi education network, that is, it can be connected to a school, higher secondary, primary schools, universities, state capitals, and then some study centers also we can make it. So this is how it is going to happen. And this figure indicates how the teacher is teaching and how it is reaching to the classroom, how the boys are listening, and then the boys can interact and then they can clarify their doubts. This is what is happening. Apart from this education, we established some remote terminals called village resources systems. Through this broadcast vans, the villages are connected to the nearby towns and state capitals, so that the agriculturals, they can come to know what is the real requirement of the people who are living in towns, so that they can produce their requirements and then meet their livelihood and improve their quality of their life. This is how the usage, and of course, this is how that telemedicine, which I have already given you separately. Next, very important one which is coming is search and rescue system. That is when, let us assume that you are driving a car, your car gets into a problem. What do? You call your nearby station fellow, so he will come and repair the car and then you can go. But assume that you are in the mid of a sea, the ship is getting into a problem and he is not able to communicate to the people nearby. Then there is one system which is, we are calling it as one beacon is established, that will be keep sending the distress signals. Okay, that is the only way. The moment the ship gets into a problem, that is activated, and then people will be that the signals will be keep on sending, and that will be picked up by the nearby satellites, and from there it will be sent to the nearest local users terminal. That is what you are seeing in number 3. Then from there it will be passed on to the main mission control center. What you are seeing it as a 4th one. Then after analyzing, they will come to know the exact location of the ship, and then they devise how to reach the ship, either by an helicopter or by another ship or by aircraft. That is being done. This is how we work and then rescue the ship as well as the humans present in the ship. Okay, this is one way of search and rescue. Next one big use, what I can say, is that cyclone warning systems. Our country is three sides being surrounded by sea. So our coastal area are always bound to be affected by cyclones. So what we have established is using our meteorological satellites, we will monitor the cyclones movement. What you are seeing at the top, you are seeing some pictures. Those images are taken every 15 minutes once, and it is superimposed so that we come to know how this storm is going to be traveling and with what speed and which direction it is going to go and how long it takes to cross the landmass. Once the assessments are being made, we alert the people and then we'll save the people by moving them out of that place so that when cyclone really hits it, the lives are saved. I think this we are doing for the past okay 20 years. But recently, the cyclone devastation and all, you people all know. But the human life loss is very minimized by this cyclone warning systems. I think now we have established, maybe I think to my knowledge, it is around 1,200 such warning centers have been established along the coastal lines of our India. This we have seen up to the usefulness of the communication satellites, then how we are planning to use our remote sensing satellites. The applications I will come in the next slide, but as far as the users, it started with central ministries, then it was come down to state governments, then private sector people started using the data, then some NGOs. Now the data collected is so much. Now we wanted to rope in universities and academia to come out with a better interpretation of the data. So that is what now is currently going on. I think we have quite a huge amount of data, what we collected from Moon as well as from the Mangalyaan. And the scientific satellites, whatever we have so far launched, like CAHCET and whatnot, all these satellites data are available so that university people along with the physicists, the scientists, they can come out with the data. Okay. See, this is our Earth observation applications wise. If you look at it, we use it for the agricultural purposes to estimate the crop acreages and then production estimate, soil and land degradation mapping, we can easily get it. Okay. Then comes forest, environmental and biodiversity studies. These Earth observation satellites are used. Then another main potential use is water bodies, which is being identified using our remote sensing satellites. Then reservoir sedimentation is another one very big area where it is being used. Then comes land use. That is that barren land as well as the how the urban populations are spread across India can easily be assessed with this observation satellites. Then of course weather and climate studies also we are making use. And this is used for oceanographic purpose also, so that we can find out the potential fishing zones. So the fishermen are being informed, and then they can have a good catch of fishes and then improve their life. Last but not the least, disaster support. Of course, disasters cannot be avoided, but how fast we can react to them, that is the most important one. So that can be monitored using this remote sensing satellites, like flood damage assessment and drought monitoring and landslides, all these things using our remote sensing satellites. How the rehabilitation programs are reaching to the needy can easily be assessed, and then accordingly the programs can be revised, and then we can reach to the distressed people and then help them to come out of their problems. Next is, okay, most important one, which I can say is our imaging capability. To start with, 1 kilometer by 1 kilometer was represented by a dot. What you are seeing in the diagram, that is that North India, one portion of our India. The same area, okay, as the optics improved, now currently we are having a imaging resolution of 1 meter by 1 meter or even less than that. That means what I can say is a car moving on the road can easily be identified. This is how our imaging technology has improved, and then we are having satellites of sub-meter accuracy, and which is being used by our defense people. Okay, for the guarding our areas. Okay, I'll not go too much into details. Of course, now we have seen communications, then we are seeing remote sensing also. Like this, scientific missions are there. Okay, to name a few things, we go for X-ray astronomy, middle atmospheric dynamics, solar flares and its storms. Then planetary exploration is coming under the big study for the space sciences program. And the 4 categories are astronomy and astrophysics, aeronomy and the planetary atmospheres, earth sciences and solar studies, then theoretical physics. These are the main application areas in terms of scientific programs. In this regard, we have already launched Chandrayaan-1, AstroSat-1, then of course Chandrayaan-2. In the last moment we had a problem, but yes, then we have launched a mission to Mars, that is Mangalyaan-1. Then we are planning to launch one exclusive satellite to study the sun, that is called Aditya. We will see a little bit later more. Of course, this Chandrayaan-1, I think most of you people will be knowing. When people were wondering why we have to send a satellite to the moon, when already other countries have sent so many in 1969 already. Neil Armstrong has already landed in moon. What is the use? But we can't keep doing only the monotonous things which we have already established, like launching a communication satellite, remote sensing satellites. But we also try to expand our horizon. Okay, as we grow, our horizon also has to grow, and then our area of activities have to be expanded. So we undertook a mission to send a satellite to moon. But ours was again a unique one. So far, whatever the mission which was launched to moon, they were all being launched going around along the equatorial belt of moon. So a complete moon's surface mapping was not done. What we did was we sent a satellite in a polar orbit of moon, so that the entire moon's surface was mapped. First time after our launch only. And the second unique thing, of course, you all know, we are the first country to unambiguously prove there is a water present in the moon. That is another feat what we have achieved from our Chandrayaan. And of course, Chandrayaan-2, we wanted to have a soft land, but unfortunately, in the last 1 minute, we had a problem, and then we were not able to successfully have a soft landing. It had a hard landing, and then we lost the contact. And then we were not be able to proceed with the rover, so that rover would have supposed to have lived for 14 moon days, and then would have had some very good data we would have received, but unfortunately we could not. But of course, anyway, that is going to be taken care with our Chandrayaan-3, which is going on in a full swing. And to meet the tracking requirement, we have established 2 big antennas, that is of 18 meter and then 32 meters. 18-meter antenna was sufficient for the moon mission, whereas our ambition idea was to have to go farther and farther, so that a 32-meter antenna was established. All these two antennas are been positioned in Ailaulu, which is nearby Bangalore, which is around some 50 kilometers away from the Bangalore city. The next is, of course, evolve Mars. Mars mission is one of the cheapest mission which has sent to Mars so far by any country. And we have done this in 18 months of time. And India is the first country where we have gone into moon's orbit in the first attempt itself. Even today, China could not do it. So by a month back, they have sent one more satellite to Mars. Okay, Russia took 7 attempts to go, whereas USA, they succeeded in the 6th attempt. Okay. This, I don't want to tell it as a boasting thing. That shows our sincerity, and then we took all the failures by other countries and we studied in deep, and then we try to avoid those situations and then try to overcome that problem. At the same time, we realized the spacecraft using our own satellite subsystems joining together, and then we realized that satellite in a short period of time with minimal budget. That's what I want to say. I think our strength lies in realizing our goal with available technology. We will not really go after technology. We will be try to achieve with available technology. That is what our strength lies, and then we are successful in all our endeavors so far. And I feel we will be continuing our success story even in the coming days. Okay. These two pictures, what you are seeing is, I just wanted to show what AstroSat, what we have launched. And Galaxy was sent by USA. You see the images. That is, that left one, what you are seeing is the image taken of the galaxy by NASA, whereas its accuracy and the resolution is 6 arcs. Whereas in the bottom, in the right side, what you are seeing is it is having a resolution of 2 arc seconds. That means the data interpretation becomes much better, and then we can have a better interpretation. That's what, like what we see our mobiles. Our cameras in olden days, it's okay, pixel accuracy was in terms of kbps. Now it is in MBs. Now, okay, people are talking of 70 MB, 100 MB and all. So that means as the number of pixel increases, your picture definition increases, that your precision and your accuracy keeps improving. That's what we are going to get it. So that is another use of our AstroSat. We get a better and precision photographs of the galaxy, and then that leads to a better study of the galaxies by our scientists. Next, as I indicated to you, this Aditya is the mission which we are going to launch to study the sun. Main objective of the satellite is the satellite is going to be placed in a point where what it is called is a Lagrangian point. I think you would have read in your earlier studies that our solar system, India, that Earth and the Sun is having 5 stable points, what called as L1, L2, L3, L4 and L5. L1 is coming in between Earth and the Sun. L2 is coming beyond Sun. L3 is beyond this side Earth. And the L4 and the L5 are the perpendicular along the L1. But we are going to place this Aditya in L1 so that one side of the satellite will always see the sun, other side of the satellite will always see the Earth. the side in which it is seeing the sun, the data is all the data packages, all the experimental subsystems will be kept in that side, and the back side, the antenna transmission sites are being kept so that 24/7 you will be keep getting the data from sun, and that data is directly received by our earth, and then we will have a better idea and then better understanding of the sun, and then the data will be shared among the world community scientists so that we can have a better data interpretation of the sun. These are all the experiments which are going to be planned, and we are planning to have one follow-on Aditya mission also. Then further in the space explorations, already I told you Chandrayaan 3 is in place. Then there is a continuation of Mars mission is going to be there. Then we are planning to send a mission to. Then this XPO-SAT, that is, we are going to have the study of exoplanets are in the pipeline. And with this kind of a program, scientific satellites, all other satellites programs are going to go, that I will go in the next few slides, so that requirements are keep growing, and it is to be met with the next generation of the people. With the present manpower strength, whatever we are having, we are finding it very difficult to meet the requirements. So new manpower is required as well as the budget requirements. That's where private partnership is been looking for, and I hope we will be soon having a kind of a mechanism where how private people are going to participate, how it is going to go. Anyway, I will come back in the subsequent slides. Next, another important area is sat-nav, positioning and navigation. I think if I ask you something, you simply, I think, go to the Google map and then say, yes, this is where, but of course, yes, GPS is currently available to all of us, but there was a position, that is, GPS consists of 28 satellites. And there was a time, yes, when we wanted a better accuracy from GPS during our Kargil war. US people denied that access. That is, we wanted to know our troop movements along the borders, but they denied us that accuracy requirement. So we were finding it very difficult. So the government was asking us, can it be possible to do something? Then we have come up with the idea of having only 7 satellites in place of 28 satellites of GPS. And the constellation of the 7 satellites are something like this: 1, 2, 3, then 2 are in this inclined orbit, 2 more are in this, so that we will be having a better accuracy than GPS surrounding our India. That is, that 1500 kilometers only we were having, and we have successfully launched. And currently we are having 2 mobile phones having this NAVIC systems, but the price of the mobile is 30,000 plus, and now people are already in the process of making it in a much cheaper version. I hope we will be able to get it soon, so that a day is not far, we will replace our own NAVIC system for the position determination in place of GPS. This is another one big area where people are still in the work, and a lot of industry people are also being contributing. Of course, this is the kind of satellites what we need, the roadmap until 2030. That is the next couple of years, we are going to add another 39 satellites. This is mainly to replace some of the satellites which is already their lifetime is coming to an end, and then we'll have to enhance the satellite capacity building. That is how this is going to happen in our communication spacecraft and the meteorological spacecrafts. Then if you talk of our lower satellites, we will be adding too many satellites, and then for navigation purpose, if you are really looking at it, our ultimate aim is to make it 15 satellites instead of 7 satellites, so that the accuracy what we are going to derive will be much better, and the availability of the satellites for the position determination will also improve, so that in turn the accuracy improves quite a bit. And even if few satellites gets into a problem, the other satellites will take care in its place. That is the idea we wanted to make it to increase, but this is going to happen, okay, within the next 2030, we are, I mean, from 7 to 15, we are doing all this. So to meet all these demands, it is in the, this is the satellite area now. Then this is our spectrum of our program. That is giving communication and broadcast, orbital astronomy, meteorological satellites, and then data relay satellites, interplanetary missions, then manned mission platforms, then a space station similar to India, the International Space Station. We are planning to have our own space station. Then, of course, LEO communication satellite systems, and then Earth observation satellite system. These are all the main things which we are going to have. And next most important thing is our human space program. That is planned to be launched in, we have our Gaganyaan mission that is going to happen in 2022. For that, the launch vehicle, it's a modified one of our GSLV Mark III. And this is the crew vehicle where the astronauts will be sitting. This is the service module. And the mission duration is roughly planned around 7 to 14 days. Anyway, then this is how the rocket is going to be launched. And then the crew will be into the orbit. Once their mission is over, we will take them down. This is how it is planned. And of course, to meet this, way back in 2007 itself, okay, there is, we have already demonstrated our capability to recover the capsule from the orbit, so that this is the kind of a capsule where we are going to send our astronauts to space and then bring them back. Okay. Whereas the main difference between human space program and then satellite launch, or satellites need not be brought down there, whereas human will have to bring them back. That is the main thing. To bring back, I need the technology. That is how to demonstrate the technology. We have done it in 2007 itself. So the work was progressing, and of course, for anything you need money. Money has to come from government. So if the money flow is disrupted, then our technology growth is also getting delayed accordingly. So, but now anyway, I think 2 years, regulation has told that, yes, we are going ahead with our human space program. So in 2022, when we celebrate our 75th birthday, our Indian astronaut, what we call them as Vyomanauts, that means they will be there in space in 2022. We all hope we will be having it. This is the kind of modification what we are planning to do, and then we have already done successfully the experiment. In case of a satellite launch vehicle, even if the launch vehicle gets into a problem, then we can safely destroy the launch vehicle to avoid its impact on the human beings present on the Earth. Whereas in human mission, we can't do that. First, we'll have to rescue the astronauts. So we have to modify the launch vehicle so that in case of any problem in the launch vehicle, first we have to save the astronauts. That is what we call is crew ejection system. That is what you are seeing in this diagram. This is the kind of a setup. With this, when the rocket is getting into a problem with its own propulsion system, it separates out from the launch vehicle and then safely it can land and then we can save the astronauts. This is what we did as a part of this experiment in 2014 itself. We have launched the module without human beings, but we have recovered the capsule and successfully. Then this also we have demonstrated. And like this, the next 2 flights are planned for 2022. We are going to send the actual launch vehicle with dummy robots. We are planning to send it to orbit and then recover. Then in 2022, we are planning to launch the human space program. Next important program is reusable launch. By reusable, what I wanted to tell you is once I launch a rocket, that rocket is no more being used. That means whenever I want to launch a satellite, a new rocket has been made. But in place of that, if the rocket stages are being recovered and then refurbished and the same thing is being used, the cost component can be brought down. That is what now, if you see Elon Musk, SpaceX, they have successfully demonstrated the same rocket with refurbishing technology. They have done 6 flights. That means with one production of the stage, it is used for 6 times. Now you compare the cost aspect. That is what. Generally, if you go with a conventional rocket, which is perishable, to launch 1 kg, we roughly spend $5,000. But with the reusable, we can bring down by 1 order. That means we can achieve 1 kg of payload can be launched with 500,000. That is the kind of a cost aspect and advantage we are going to get. For this, already work is in progress. We are planning to use it air breathing engine, and we have already demonstrated this. And then as a landing part, yes, we have already done in the 3rd phase, and then we are left it to 2 more phases so that we will have one equivalent of reusable launch vehicle maybe sometime in couple of years. Next, okay, as far as the revenue generation is concerned, many countries are approaching us to launch their micro satellites and mini satellites. So what we have come up with an idea of designing a small satellite launch so that this launch vehicle is all solid stages so that the launch can be done in a week's time. That means the rockets are planned to, stages are planned to be assembled and then launched in a week's time. That is a kind of a time schedule we are working out. Already there are customers who wanted to launch through this. That shows their our strength and then their depending upon us and then their hope of our reliability. That means they are sure that we will be definitely successful in our ventures, and then they are confident that their satellites will be launched successfully. That is what the confidence what we have built among the world countries. So, okay, this is another one major program. Next is a 2-stage to orbit. That means this is somewhat ultimate one, like a aircraft. Now the aircraft takes off in one place, lands it in another place, like that. We wanted to have a takeoff, launch the satellite, and then again come down. Then again you go back and then launch it. This is a kind of a vehicle what we are planning, and this is also in an advanced stage. And then we should be able to demonstrate this in a short interval of time. Next is, of course, this is see, okay, long-term plan to have a very high launch vehicle, heavy lift launch vehicle. Currently, what we are having is 10 ton in the low Earth orbit using our GSLV, whereas our idea is to have 100 tons in the low Earth orbit so that you can send a human being to Moon and Mars and then bring him back. This is our manned mission to Moon and Mars is the long-term plan, and for that we need heavy lift launch vehicles. And corresponding to that, yes, already there are stages we are started advancing our our programs, realizing the propulsion system, stage systems, and then guidance and control. And then we are going ahead with advanced technologies and all. But to meet all these things, it's not only we need money, we need manpower, brain, and then we want to have a dedicated workforce. For this only government is planning to achieve. How that is going to be achieved, I will come shortly. Like the spacecrafts, number of spacecrafts, what is the roadmap for the launch vehicles development you are seeing? Instead of having the dedicated launch vehicles, whatever launch vehicle stages available, we assemble in an assorted way and then try to launch to meet the growing demands. That is what you are seeing, that multiple arrows, whatever you are seeing. This is how the available stages will be stacked together and then we will meet the requirement. So this is the kind of a thing what it is planned to have. Of course, the vision, everyone should have the vision. The main vision is it should be an inclusive growth. We should have a knowledgeable society, and then we should be again going to be come as a developed nation. So that education should be for all, health for all, empowering the rural community. This is the one main aspect of what our India, because it is rural component is much higher. Then comes, of course, resilient society. To meet this, yes, we have already planned the roadmap, and then yes, it is going to go. For this, we have 5 new space age E's. One is exploration, and then exploitation of the resources available, then engineering, that is whether it is a robotic technology or deep space missions or return missions to Mars or Moon kind of a thing. Then enterprises, that is how are we going to make use of the space assets, space tourism. I think now this is one of the new thing in another 10 years. I'm not surprised to see many people to go to space and come back, like what we are visiting now foreign countries. 20, 30 years back, okay, visiting a foreign country itself was a great thing. Why? 40, 50 years back, okay, traveling by air to our nearby place itself was a dream. And I joined my aeronautical engineering in 1975 in Madras Institute of Technology. Okay, at the time, the number of aircrafts available were not even 3 digits. But now see the number of aircrafts available. So that is the kind of growth you see. But so far, only 3 private entrepreneurs have gone to space and come as a space tourism. But in the next decade, I'm not surprised to see that number will be easily crossing into 3 digits because of this advent of this. Then, of course, everything when it grows, we need to have a proper governance, that is space governance, and then space security. So these are all the areas now. There is going to be a concentration of work worldwide. Now we have to come out of the boundary of only one country. Now, as a whole world, now we should work to achieve all these things in totality, and then we can make use of the space resources. Now, opportunities wise, if you see the space program, recently, as I told you in the beginning, government has promulgated an ordinance for private. there is a separate vertical is formed called INSPEC, so that this INSPEC is a body which is taking the private industry into their fold, and they will come out with a program of their own launch vehicles and their own satellites, and how they are going to be launched, and they are going to build with the help of ISRO. It is already been planned, and the policies are being worked out, and then it is coming out. And next area, what I'm seeing is unmanned aerial vehicles and then robotics. I think probably you would have seen that the drones applications and then subsequent usages. But currently, whatever drones we are talking of are only a few kgs, that is 10 kg, 20 kg. Whereas in the near future, the war field is going to be done using unmanned vehicles. That is DRDO is, that is a Defense Research and Development Organization is going in a big way to develop unmanned vehicle of 1 ton, 2 ton, and then so that it is capable of carrying warheads and then take it in the war field and then go into a next paradigm of shifting in the war field technology. So there also our space is going to come into the picture. Next comes, of course, as I told the World Space Agencies, we are going to cooperate and then somehow joint programs. If you really see the budget of the World Space Program, it is roughly around $360 billion, and it is likely go to 1.1 trillion in 2030s. This is what the assessment given by a study by the Foreign National. And even if you get 0.1% of this budget to India, you know what is the kind of money we are going to get? We are going to get 30,000 crores, 0.1% of this budget, to just imagine. Even if you get that kind of a share in the world space market, I think our Gaganyaan project, it is only 10,000 crores. So that to that double that amount we will be getting yearly. So that is the kind of a revenue what it is being talked of, and that means the kind of a work force you require, the kind of expertise we require, the kind of various disciplines of engineering we require are quite huge. So you don't bother which is your branch of study. Come out in bright colors, successfully complete your base education, and then get very good marks. That is the opening for you, and you will definitely have a very good future. Okay, that is, though I have put it is 2% because I always want to be an optimist. But even if I get 0.5% out of this, I think it's a very huge money for us, so that we can have a lot of startups. I think, to my knowledge, already there are more than 2,000 startups in this business, the space program business, which is being already engaged, that then they are using it. They are getting, even in India now, you would have seen a lot of people are already coming out, and then they wanted to do their own with the support of industry people. And already ISRO, we are having all our programs, that is that satellites or launch vehicles. We are having more than 150 plus private industries like Tata's, GE, Birla's, and then all these people, they are already contributing. But that number should grow, and the kind of money flowing from the private industry also come up. Then I think we are in a very good way, so that other countries like USA, Russia, all those things are going to be contributing to this. And that will increase our domain knowledge, and then we can contribute, and then we can utilize our workforce. That's what I just want to emphasize. Before I conclude, I will say that the vision for 2025, maybe you can make it to 2030 also. the operational services needs to be continued, and then we have to have enhancing the existing capabilities, and then weather climate resource management are to be continued, and then will have to improve. Then space science missions to understand the solar systems and the universe need to be improve. That development of heavy lift launch vehicles, you have already seen what for it is. Then lunar and interplanetary and exploratory missions, as we are already seeing. Moon, we want to make use as a base to go to Mars and then establish the colonies in the moon. Okay, I think they may not be far, so that our Earth will not be sufficient to have a decent life of the mankind. So, because the population is increasing, the resources available are limited, and one day, maybe you and I may not see, whereas in the days to come, the resources all will get depleted. Then you should look for the resources, or you'll have to look for somebody somewhere else. So that is why we are talking of this colonizing the moon and Mars and what. Okay. Next is, of course, reusable launch vehicle, and then go stay into the orbit. Then, of course, last is not the least is human space flight. This is our, okay, presently our, okay, next immediate goal is to have this human space flight. I think by 2020, 22, we should have two to three of our Indians will be in space, and then they will successfully back to India. Like you all, I'm also eagerly waiting to see that day, and then all the very best for them. I think I'm sure that we will be able to successfully launch the biomonarchs, and then we will receive them back. I hope was the audio available to you. I think the main thing is, yes, of course, as I told you, this is our vision. And before I conclude, I think I used to, this slide is my, okay, master stroke. Sky is not the limit. Nothing is impossible with the hard work. Similarly, nothing is possible without hard work. We Indians are better among the best. Okay, all the very best for you people. Thank you for your patient listening. Now I leave the floor to, okay, Dr. Vadivel and then Dr. Abdul Wahid. Thank you so much.
Thank you very much, sir. Am I audible, sir?
Yeah, I think.
Thank you very much, sir, for your informative and interesting speech, sir. So there is a lot of comments from the chat box, and they have given a positive feedback about this webinar. So we are very proud of you, sir. So we have a few questions, sir. Let me start with the question and answer session.
Yeah, please.
So first question from Hari Shankar. He is a research scholar. So he asks that how do rockets resist with electrostatic and electromagnetic fields? How do rockets resist with electrostatic and electromagnetic fields?
Yeah, okay. But what we call it as EMI and EMC, electromagnetic interference and then electromagnetic conduction. So these two things, mainly these will affect electronic systems. Like if you talk of rocketry, in the initial days of rocket, it functions for only, maybe to an extent of 15 to 20 minutes. When it crosses the heavy atmosphere and then goes out of 10 to 15 kilometers, then it is only a vacuum and only space environment. So the electromagnetic interference, what we will study the extent, and then we try to shield them so that the external interferences are not affecting the normal functioning of the control system or other the devices which is housed in the rocket. This is the case with rocket, whereas a satellite, when it is going around Earth, that is when it is that Van Allen belts and all, when it is crossed, yes, you know that the interference will be much more. There also, yes, we have a shielding mechanism so that these interferences are already taken care, and then that effects are being nullified, not to affect the functioning of the spacecraft subsystems.
Okay, sir. Okay. So another question. So this one of the question from Dr. Vasudha. So she is asking that what is the role of navigation satellite system in monitoring wildlife?
Monitoring wildlife. Okay. The problem there is, yes, but per se that wildlife now what they are doing is like you will be seeing by that wildlife authorities like that lions and then all these things they are now putting with some kind of a device which is injected into the body, or they are just like our earrings, they are putting something. With this, they can have the track. That's all it is. After all, monitoring, where is it? The position monitoring. Like now with your mobile, you know how it is determined. That is the satellites, the signals are being monitored, and then the satellite is sending the exact position to the mobile phone. Like that, the device which is sitting in the wild animals, it can easily be detected and then they can be monitoring. And that device, it is necessarily to be implanted, otherwise it is difficult to track. Because with the photography, it is very difficult for me, for the navigation satellites to identify. Because the resolutions are required is very high. That is a little bit difficult. That what they call it as the radio collaring technology. Using that, yes, of course, our navigation satellites have been made used to identify the wildlife, and then, okay, we can come to know their statistics, and then its evolution and its growth, all those things can.
Okay, sir. Thank you. Thank you very much, sir, for your informative speech. And also, it is more valuable to us, sir. Now, I would like to call upon to propose vote of thanks from Abu Bakr.
Thank you, sir. Very good afternoon on all present here. Good afternoon and good evening. Is there my voice is audible, sir?
Yeah, you are clear. 5 by 5.
Yes. Okay, sir. Thank you. It is my great honor to propose a few words of gratitude to all who have been a part and helped us to making a grand success of the program. We have been fortunate to have such an eminent person, Thiru T.K. Sundaramurthy, Mission Director, retired, ISRO, Bangalore. It is my sincere and heartfelt thanks to you, sir, for your exceptional contribution and valuable motivating speech to future generation. And I thank to you, sir, on behalf of our college management, correspondent, principal, head of the department, Science and Humanity, and Faculty of Physics, Faculty of Physics Department, Sri Abdul Hakim College of Engineering and Technology, Mel Bishar. I take this opportunity to express my deep regards and gratitude to our management and correspondent for always encouraging us and providing opportunities to organize such programs. I would like to thank all the participants, students, faculties, research scholars, and industrial persons for their strong support to conduct the event successfully. I thank our respected principal, head of the department SNH and faculty of physics department C. Abdul Hakim College of Engineering and Technology for their idea and motivation give me a successful completion of the program. My special thanks to coordinator Dr. Izzat Abdul Wahid sir, head of the department SNH, and conveners Dr. S. Vadivel and Mr. A. Ubaidullah, Department of Physics SNH, for their hard work to reach the program in a resounding success. Finally, I would like to thank Mr. M. Nishad Ahmed, Assistant Professor, MCA Department, for arranging a great media platform to reach the webinar successfully. I thank you all once again. Thank you very much.